So just getting started. So this is basically the core, if you will, module in Phosphor. When people come and they use Phosphor, they're probably going to use it for their widgets, although we do make an effort to make all the various packages kind of self-sufficient and usable on their own. Probably most people are going to get started with Phosphor in one way, shape, or form because of its widgets, whether that's the dock panel, which is and most likely because it's a good implementation of dock panel, or some of the other widgets that are hard to implement on your own. So at the bottom of that widget stack is this base widget class. So any widget in Phosphor inherits from this class widget, and this is not a small class. What is this file? Almost 1,100 lines of code, and all of it is important. I don't believe there's much private implementation in this file. But one thing we are going to notice is the number of imports from other Phosphor packages at the top of this file. So we've got algorithms, disposable, messaging, properties, and signaling. That covers quite a bit of the core Phosphor packages. So immediately what we're seeing is that the 0-day reason of existence for all of those other packages in Phosphor is because they're consumed by the widgets package. So while they are useful patterns on their own, I didn't just write them because they weren't needed. There was an explicit need for all of these separate packages, and in this case, it was to serve as the foundation for building a competent and pluggable widget library, which is Phosphor widgets. So hopefully we could actually start seeing where all this stuff is going to start tying together, how all these patterns are actually going to be employed in an actual library and in actual usage. Moving right along. So let's get right into it in the widget class. And so the first thing we're going to notice is that this widget implements two of the core patterns in Phosphor, which is the disposable pattern and the message handler pattern. So if we recall or you can go back and rewatch those videos, the disposable pattern is a very simple interface. It's an object which has a method called dispose, and it has a property which is read-only, which is disposable, and it returns a Boolean whether or not the object is disposed. What this is useful for in the case of widgets, so if you jumping a little bit ahead, so widgets kind of form a hierarchy with parents and child relationships. And in most UI toolkits that have some sort of concept of a widget, it might be called widget like it is in Qt, QWidget, or in WX, it's called a window, a WX window, everything inherits from that. I'm not actually sure what it's called. I think it's an element in C# or WPF. But what they all have in common is that you have a hierarchy of these things. So you have parents and you have children, and it forms a tree. You have this in the DOM as well. So nodes have their own, DOM nodes have their own parent node, and they have their own children nodes. Iterating through them between the different frameworks is all a little bit different, but it generally form a tree. And when you dispose of some node in a tree, the logical thing to do is to dispose of all of its children and all of its descendants as well. It's because you're done with that part of the tree. And so having all of the widgets implement this disposable interface makes it very, very easy for us to write an algorithm that will recursively defend the tree and dispose of everything within it in a safe way. So we don't need every single widget implementation that ever exists to come up with its own way to dispose itself. You just implement the disposable interface, and then the base widget class can handle that for you. So we broke this out as a separate pattern rather than just defining like an abstract class or something like that. We could have defined this as, export abstract class widget and then force you to implement in your child your own widget implementation or your own subclass, the dispose method and all of that, but it's just cleaner to define it as an interface, break it out as a separate package, and then have some utilities surrounding dealing with disposable objects. So that's why that interface exists at its core, and also it's broken out into separate packages because it's a generally useful pattern. Similar to the disposable interface, or perhaps a little bit more generic, is the message handler interface. So if we recall, the definition of iMessage handler is an object which implements a process message method. And this is perhaps even more useful than the disposable interface on widgets because this allows parent widgets to communicate information to its children or to its parent itself. So it allows it to pass messages throughout the hierarchy, throughout the widget hierarchy, and the key here is independent of whether a particular widget can actually handle that message. So if we recall the contract with message handlers is that, they have a method called process message. So somebody's going to send you a message, that method is going to get invoked. And then it's up to your implementation of that handler to decide what you do with that message. You're still going to get the message. You might not have to act on it. If you don't handle that message type, you don't have to, you just do nothing. And so that one level of indirection allows all sorts of flexibility when it comes to layout widgets, sending messages throughout the widget hierarchy, and not having to worry about whether any particular subclass of widget can handle those messages. A particularly good example is the resize message, which we use all over the place in Phosphor. And this particular message is used to notify a particular widget that it may have been resized. So this is something you don't get from the DOM. In the current DOM standard. A little bit of notable history, Internet Explorer versions 10 and earlier did have a JavaScript event that would be fired on each individual DOM node when that DOM node was resized. That's really useful. That's basically the behavior that I would like to have to be able to hook into in the DOM and Phosphor and have to have resized messages. But it wasn't part of the official standard. And Microsoft took a bunch of flack for having that feature in Internet Explorer when none of the other browsers, standards compliant browsers, had it. So they got rid of it in IE11. And basically IE11 and Edge going forward, they don't have that resize event. And then Google comes along and decides it would be nice to have resize events, so they implement the resize observer specification and take all the credit for it, like they were the first ones to invent it when it actually existed in IE for a long time, and then they got rid of it. So just a little historical aside, something like resize events is coming down the pipeline again, but it's not in the official spec, and no spec compliant browsers actually implement it yet. So anyway, what we needed to do was have a way for widgets to be notified when they have been resized. And the reason for that is that we have a bunch of layouts that are implemented in Phosphor, in JavaScript, that do things that you can't accomplish, that perform layouts that you can't accomplish with just regular CSS as the current CSS standard exists. And in order for them to lay things out properly, they need to know when the container that contains all of the child widgets that they're laying out has been resized, because you need to refit all of those children to the new available space. And up until now, the only way to do that would be to either pull the DOM on some timer to check to see if things have been resized, which is very inefficient, or listen to the top level window resize event that does exist in browsers and is part of the standard. And that works, but it breaks down when you've got something that happens with inside the browser window that causes something to resize, that it's independent of the browser window itself resizing. A particular example of this would be grabbing a splitter handle or a divider in the dock panel and kind of dragging that back and forth, like we have inside of JupyterLab to resize your document or make the file browser panel wider or something like that. So that's a resize that happens to your widgets independent of the actual browser window resizing. And so when that happens, you don't get the resize event in JavaScript because the window hasn't resized. So we need some way to reliably notify widgets that they've been resized. And the way that we implement that is by passing around resize messages, which implement the message interface, and we send them to the child widgets. When the parent itself has been resized, it notifies its children that they may have been resized, and so on and so forth. That resize message propagates down the widget hierarchy, and widgets in their layouts are able to react to that resize message if they need to, or ignore it if they need to. So this is why the base widget class implements this message handler interface, so that all of the other widgets that are ever defined also can handle the variety of messages that are passed to widgets. And as we'll see when we get down here, there's quite a number of different messages that are sent to widgets by default by the framework, and that's in addition to any custom messages that the user might send to various widgets. Okay, so introduction aside. So the constructor for a widget will find this pattern basically all over the place in any of the default widgets that are defined by Phosphor. If they take constructor arguments, they're always in the form of an options object. And this allows us, the reason we have an options object rather than just a variety of positional arguments is that this allows us to extend the options that can be given to a widget without breaking APIs. So if we had, for example, the base widget class took 0 arguments, and then at some point in the future we want to add an argument, an option that could be taken by the widget. That might not be an API compatible change, because you might have somebody that's already subclass widget and is already calling super, and they're calling super with no arguments, but now widget requires an argument or something along that form, and you might end up breaking APIs. By just defining all of the widgets to take an options object, we can always go back and add further optional arguments to this definition of widget.iOptions, and that is an API compatible change going forward. So you never have to basically break someone's API or break the usage of the Phosphor API by adding more functionality, more optional functionality to any of our widget classes. And so that's why you'll see this pattern basically all over the place, that widget classes will take an iOptions object, and any subclass of widget will inherit from this interface for their options object, and so on and so forth. So it becomes very, very easy to extend and add functionality in the future. So the first thing that the widget does is create the node for the widget. So in Phosphor, every single widget represents one node in the DOM. Now it might represent a node and some descendants of that node, but at the core there is exactly one node that is owned by a particular widget. So in the case of the plain widget, it's just a plain div that has some we'll see what the options definitions are, but this just creates a plain old div and assigns it to the widget. And that might be we'll see later on with the options object, you could change what the node is for the widget, but by default it just creates a div. We'll see also when we get into some of the other more complicated widgets like the tab bar. The tab bar itself is also represented by a single node, but it has child nodes such as the inner node, which contains the tabs and the tab nodes and that sort of thing. But for the base widget class itself, all it represents is a plain div. And if you just call new widget, you're going to get a widget with a node that's a div. The next thing we do is start adding class names to that actual node. So this add class method, this is just a method on the widget. That's a bit of a convenience so that you don't always have to go widget.node.add class. And it also abstracts a little bit around browser incompatibilities with regards to the toggle class, so toggling the presence of a class on a node that's different between Chrome and Firefox and IE. And so I've defined basically convenience, add class, remove class, and toggle class methods on widget to handle that for us. So the first thing we do is start adding class names to the node. So the reason for this is that so you can track, if you're actually opening the browser inspector or you want to apply styles based on CSS or that kind of stuff, you have the ability to do that in a way that is consistent throughout all of the widgets. And so the pattern that Phosphor takes, which is a pattern that we also follow in JupyterLab, and a pattern that's suggested for any library, any users of the Phosphor library, is you tag your widgets with a class name that is the same, or at least suffixed the same, as the name of your class in TypeScript. And so what this allows you to do is when you're inspecting the DOM from the browser, you'll be able to see the class names that are tagged on a particular node, and you'll know where in your code that class name was added, because you can just grep for the same class name. Now, since CSS is a shared global namespace, until Shadow DOM and all that kind of stuff kind of makes it into supported standards, you need a way to distinguish classes that your library has added from classes that somebody else's library has added from classes that Phosphor has added. And so Phosphor basically reserves the P- prefix. So here's a hard rule. Any single class name that is added to any node by the Phosphor library in the DOM will always be prefixed with P-. And this also works for, should also work for data attributes and IDs and that kind of stuff. So if the Phosphor library is tagging something in the DOM, that tag will be prefixed with P-. That means Phosphor put it there rather than your own code. What we do in Jupyter and JupyterLab is that any of the classes or the datas or the IDs that are tagged by the Jupyter libraries are prefixed with JP-. And so if you're a library author and you're using JupyterLab libraries and you're using Phosphor libraries, you'll be able to know by looking at what the class names are whether it was Phosphor that put it there, whether it was Jupyter that put it there, whether it was your own library that put it there, because things are basically namespaced on those prefixes. Secondly, whenever we have a subclass of a widget, so let's say one of the things we're going to talk about is the panel widget, which is a subclass of widget. Phosphor is also going to add p-panel class name to that node. So a panel is going to have two class names. It's going to have p-panel. It's also going to have p-widget. You're going to get both. So what that means is that as you go down this subclass hierarchy, every single subclass in that hierarchy is going to add its own class name to the node. So when you're looking at this in, let me see if I bring up an example here. Just bring up an example application here. If we look at this tab bar up here, we can see that this widget is it's a tab bar, and it's also a widget because tab bar inherits from widget. And then we also have this other thing where the dock panel itself is tagging this tab bar as a child of the dock panel. So not only do you know it's a tab bar widget, but it's a tab bar widget used in the context of a dock panel. So that helps us when we're going to go apply kind of specific CSS styling. Let's say I want to style, instead of all the tab bars in my application the same way, I want to specialize the dock panel tab bars. I have the ability to write CSS selectors that target those things. So that's kind of just an intro into how we start specifying our CSS classes in Phosphor. And it's one of the first things you see when you create a Phosphor widget. All right, moving on. So the dispose method on widget. So always good to read the notes. So it's unsafe to use a widget after it's been disposed. This is kind of universal for any disposable object. After you dispose it, there's no guarantees made to what the behavior of the application will be if you try to use that object after it's been disposed. So this isn't C++, so it's not like we've deleted the object and you're going to get an access violation if you try to use it after that. It's still a JavaScript object. It just will have undefined behavior after you dispose it. The only exception to that rule, and it's also defined in the notes of the disposable interface, is that you must be able to call dispose multiple times on an object. And the rule is that the time that you call it, if you call the dispose method the second time, it's a no-op. In fact, anytime you call dispose after the first time, it must be a no-op. So the first thing we do is check if object's already been disposed, because that must also you must also be able to check the is disposed flag after an object has been disposed. So if we've been disposed, we do nothing. That's a pretty easy check. We do this basically all over the place, and that in and of itself ensures that any calls to dispose after the first are a no-op. The next thing that we do is we set a flag. We'll see what this set flag does a little bit later on, but in short, there's a bunch of Boolean flags that are on widget that you might care about. Is disposed being just one of them. Rather than storing all of those flags as separate Boolean internal private attributes on a widget, I store them as basically an integer bit mask to save the memory, because we're dealing with JavaScript. They've got 8-bit or 8-byte pointers. So rather than taking up 8 bytes for every single flag, I'll take up 8 bytes for a single integer, and then basically flip the bits of that integer to store the Boolean flag. So you might be creating thousands, if not tens of thousands of widgets in your application, and so to be as very efficient as possible. This is kind of exemplary of one of the tenets of Phosphor development, which is sweating the details. And performance matters, and performance both in terms of runtime and in terms of memory use. And so we want to be as fast as possible and as small as possible while accomplishing the goal. So there's no need to store a bunch of Booleans when a bit mask will do the job. So that's why we have these flags. So we set the flag to let us know that we're disposed. And if I actually go down to this is disposed flag here, or is disposed attribute right here, it's just testing the flag. You actually see this pattern in Qt if you dig into it. If you dig into the QWidget code base, it also has a similar functionality for setting and testing flags. So this test flag method just returns true if this bit is set, and this widget.flag.isDisposed is just basically a number defined for that bit. And so yeah. And so we set the flag to make sure that is disposed returns true. If dispose is called, begins with that first. The next thing we do is emit the dispose signal. Now this is something we talked about back when we talked about the disposable package on the iDisposable interface, about whether we wanted to define a signal as part of the interface, so that, you know, if you implement the disposable interface, you'd also have to implement a dispose signal. And we can't go back and add that now because that would be a breaking change. So if we added it, it would have to be for Phosphor 2.0. But secondly, the reason I said that the reason that I didn't add it was to save the memory, because not everything that's disposable needs to emit when it's been disposed. Sometimes you don't care. And so rather than force that on everybody to take that memory hit when they don't actually need it and don't care about it, I just left it off the interface. In the case of widgets, it is really useful to know if a widget's been disposed and to be able to observe that, particularly for something like the tab bar. So that when a widget that's associated with the title of a tab bar or something like that is disposed, the tab can automatically be removed from the tab bar, and so on and so forth. And so it is very useful to be able to listen to a signal that's emitted when widgets have been disposed. And so you get that by default on the base widget class. It's just not part of every disposable object. So we do emit that. So that's emitted before this logic executes here, which is what actually tears down the widget hierarchy. So we set the flag, say that we're disposed, we emit the signal that says that we're being disposed. Notably, at this point, when this signal is emitted, the widget will report to something that's consuming it that it has been disposed, but it still has its parent, it still has its layout, it still has all this other stuff. So it hasn't been fully torn down yet. And that's important because somebody that's, you know, using this or consuming this might check to see what the parent of the widget is. They might need that information. They might need something about the widget in order to do their job. And so we try to basically let people handle the widget or consume the widget as much as possible before we finally tear down the widget hierarchy. And that's basically just done as a defensive coding measure. We could have put this dispose signal after all of this at the very end, but then it becomes much less useful because now the entire hierarchy has been torn down. You might lose your place in the tree. You might not have enough metadata around the widget to do what you need to do to clean up after it. So that's why this dispose signal is emitted before the teardown of the tree.
We couldn't have put it after the signal clear data, obviously. But
obviously, yeah, because that closes down. But it could have been done. It could have been done potentially after we've torn down the tree, but that would be objectively less useful. So that's why it's emitted before. So do whatever cleanup you need to do as an observer, and then we tear down the tree. So the next block is it's either removing the widget from its parent or detaching it from the DOM if it is the root widget in the hierarchy. So if it's the root widget, it's not going to have a parent. So this block won't execute. Otherwise, if it's attached to the DOM, we detach it from the DOM. I think that makes sense to everybody here. The next thing we do, so that basically, so this, I keep scrolling around. So this block removes this portion of the tree from the hierarchy. So now after this block executes, we've got basically a separate, what do I want to call it, dangling portion of a tree out there. The next thing we need to do is make sure everything that's a descendant of this widget is disposed. And that's the job of the layout if it has one, because you can only have children of a widget. You can only have child widgets if you have a layout. And so the dispose method of the layout is actually going to take care of disposing all the children. So we check to see if we have a layout. If we do, we dispose it and then clear it out. And then we clear out any pending signal connections, any pending messages that have been posted but haven't been delivered yet. And we clear all the data associated with any attached properties that we may have. And this is done at the base class so that you as a subclass author that's extending widget, you don't have to worry about it. The very last thing that's ever done is clearing all of this metadata associated or any attached data associated with it.
Chris?
And let me finish one thought here real quick.
Sure.
And so the important thing to note here is the previous statement I said where the last thing that's ever done is clearing all this metadata. That's only true if the last thing that your subclass does in your overridden dispose method is call super.dispose. And anybody that's written C++ code before, this is going to feel very natural to them. When you subclass in C++, the first thing that gets run is the initializer. When you instantiate an object, the first thing that's done is the initializers of your superclasses are run. So the base class is initialized first, then any subclasses in order of subclassing hierarchy. That's for the constructor. When you delete something and destructors are run, they're run in the reverse order. So the destructor of the most subclass is run first, then its parent, and then its parent all the way up until the base class destructor is run last. And so that's the behavior you should mimic when you're writing your TypeScript code, because it's the most logically correct. So the first thing you should run if you've got an overridden constructor is called the superclass constructor. And the last thing you should run in your dispose method, if you've got an overridden dispose method, is calling the superclass dispose method. And that ensures things are constructed in order from base to most subclass and destructed in order from most subclass to most base class. Hopefully that makes sense. And Phosphor follows that pattern everywhere. If it doesn't, it's a bug, and we should fix it. So what was your point, Jason?
As a pattern for subclassing, the very first thing is to check that is disposed, right? And then
Yep.
the very last thing is call super.dispose.
It depends on it really depends on what your class is and what data you're clearing. If you're just setting a bunch of things to null, setting a bunch of things to null twice is by definition a no-op. Yeah. And since also by definition any dispose method must be it doesn't say you don't have to execute the body of the method. It just says that it has to be a no-op. And so should your subclass just set a bunch of things to null and then call super.dispose, well, calling super.dispose twice is by definition also a no-op. So it really just depends on your class and what you want to do, if you want to have that extra if block in there or not for code cleanliness. If it's not necessary, like if I'm just clearing a bunch of data and not actually performing any actions, then I'll just clear the data twice and I won't check if it's been disposed or not, just because it keeps the code a little bit cleaner.
And I'll just add also that if you plan on emitting any other signals, it's really important to call that super.dispose at the bottom, because it's going to clear any handlers that you have.
Yes. Yep. Okay, moving on. We've got this read-only property for disposed, and this just returns the disposed signal. If we recall from the signaling module, there's a definition of an iSignal interface, and there's an object which is a class signal, and the class signal has a method on it called emit. And if I had just exposed the disposed signal as a read-only property of signal rather than iSignal, then anybody, any user of this class, would be able to take that signal object and call emit on it, because the emit method is defined on the class but not the interface. And so this little pattern, you'll see it all the time, where we just have a read-only getter which returns an interface, but actually what it's doing is returning the internal private object, which is the full signal object. This means that my class, in this case the class being widget, and only the class widget, can actually access the emit method on the underscore disposed full signal object. But anybody that's accessing it through the public interface just gets the iSignal interface, which doesn't have an emit method. That means third-party users of a widget instance can't emit the dispose method, which you don't want. All you want them to be able to do is connect and disconnect from it, because the widget owns the signal and not those third parties. So you'll see this pattern all over the place. So I don't know that I'll cover it again, but basically the class itself stores a private underscore variable, which is the full signal object, and exposes it through read-only properties that connected to the iSignal interface.
But Chris, this doesn't protect against JavaScript users that are ignoring the typings.
No, but JavaScript users can already do a lot of damage, because they can basically.
There's all sorts of other stuff. Yeah.
At the end of the day, yes, it's a JavaScript, and much like Python, we're all adults. So if a JavaScript user comes along and starts abusing things or not using the typing system, kind of all bets are off. Kind of my rule for Phosphor is that the first question you should ask somebody that says there's a bug is, does your application compile? And if it doesn't, we're not at the point yet where you need individualized support. So this is why I like compilers, because they put a layer between you and the riffraff. So the next thing that we have is a read-only. This is the actual DOM node that's associated to the widget. So this is created here on this line 53 in the constructor. So that's a public element. So anybody can actually grab the DOM node at any time and do whatever they want with it. This particular point here is a compromise between security and convenience, if you will. Yes, it would have been possible for me to create a widget class that is more locked down and basically entirely hides the DOM node from the user, so that you couldn't actually ever access the DOM node ever, and you'd have to go through public widget APIs to do whatever you wanted, and we could keep it relatively locked down. However, if you actually look at the DOM interface for a node, which is an HTML element, it is absolutely enormous, and it'd almost be impossible for me to present an API for the widget class that would be flexible enough to suit everybody's use cases. And at the core widget class level, we need to be pretty flexible. And so this is where the compromise comes in. I do have a lot of convenience methods on the widget class for doing lots of things with the DOM nodes. And a lot of widgets are assuming that they are really the only one messing around with the node. But there's always going to be something that it can't handle. Like maybe you actually need to grab a hold of the node and do some searching around through the DOM hierarchy for this widget for some use case that I haven't thought of. In that case, this is your escape hatch. So should you, as a user of Phosphor, be messing with the DOM nodes directly? Probably not, usually not, but that's not always the case. Maybe there's a time you need to use it. But if there is a time that you need to use it directly, you're going to know it, just by the nature of, you having worked with the library for long enough to know that you need to mess with the node directly. So yes, it's exposed. Should you use it with caution? Yes, you should use it with caution, but it's there if you need it. And so this is just a consolation to practicality and convenience over security. You could really shoot yourself in the foot by doing something wrong with the node. For example, if you start adding child DOM elements directly to the node, independent at the same time that you have a layout installed on your widget that's managing child widgets, you're probably going to have a bad time because the layout's probably assuming that it's the only one managing the child elements of that particular widget's DOM node. So that's an example of where you can shoot yourself in the foot. So, but if you're just creating your own custom widget, like let's say for example, you want to create a widget that hosts some React element that you have defined somewhere else. Like that's how you would do that. You would just create your widget subclass, you would instantiate it, and you would manipulate the node directly by calling react.render or whatever it is that you need to do into this DOM node directly. So hopefully that's clear. Next few things are a few booleans which test those flags. So the first is whether the widget has been disposed or not. The second is whether the widget is attached to the DOM or not. And by attached to the DOM, I mean that the node that is owned by the widget is inserted to somewhere within the document body. So this, the way that you could test this with the regular DOM events would be, you could say like if document.body.contains widget.node, then you know that the thing is attached. However, that can be sometimes an expensive test depending on how deep the DOM is, how nested the thing is in the tree, and similar to how Phosphor passes along resize messages throughout the hierarchy, it also passes along attach and detach messages throughout the hierarchy, and it costs us no extra space to store this flag because we already have the flag for the disposed property, which we must have. So it costs us no extra space to store a flag for whether the widget is attached, and it's much faster to test the flag than it is to do that test whether the document body actually contains a node. So that's why it's stored as a flag rather than using the native JavaScript methods. Okay, also we have two flags, whether the widget is hidden and whether the widget is visible. Now note that these are two different things, and the behavior is more or less the same as what's defined in Qt. So whether the widget is explicitly hidden, and so the way that Phosphor implements this is if you show hide a widget, when you call hide, it sets the visibility of the DOM node to none, and so that removes it from the document. it's still in the document, but in terms of CSS and layout and flow, it's like it doesn't exist. So it sets the, it doesn't set the visibility hidden, it sets the display property, CSS property of the node to none. And so that's what hidden means. Now, whether something is visible, it doesn't necessarily mean that it's hidden. So again, hidden means that the display property or the display attribute of the node is set to none. Whether something is visible, it means that it's not hidden, but it also means that none of its ancestors are hidden. Because if you've got a node with a bunch of descendant nodes, and you set that parent node's display to none, then all of the descendant nodes are also not visible on the page because they're descendants. So it's like they don't exist either. So that's what visible means. So visible means either your widget has been explicitly hidden, or there's some ancestor in the widget hierarchy that has been explicitly hidden. Does that make sense? So that's why there's two properties there. So one is whether the widget's been explicitly hidden. The other is whether you or any of your ancestors have been explicitly hidden. And those are two separate behaviors. And sometimes you need one, sometimes you need both. Or one or the other.
Can I just flag that the CSS visibility attribute has nothing to do with these things, and the CSS visibility hidden field, that's a totally separate concept, just to make sure there's no confusion.
Yes. Yep, thank you. Okay, the next is something we covered 2 weeks ago when we covered the title module. This is just an attached property which returns the title associated with the widget. And again, this is an attached property, so it's created on demand. So unless you actually need the title for a widget, you never pay the memory overhead for creating the title for that widget. And I believe this is the only attached property for the base widget class. Because it's so rare, everything else is used all the time. So they're actual real private attributes. But yeah, so there's a title. And given a title object, you can always go back to the widget which owns it because the owner property of the title is set to this widget. The next few are just conveniences for accessing the node, the ID of the DOM node and the data set of the DOM node. So similar to how you can add class, remove class, toggle classes, we'll get to those methods down below. You can get or set the ID for the DOM node as you need to. Again, this is just a convenience. And you can get the data set for the node, again, just a convenience. And this returns back the actual DOM string map. Note a little bit about layout for the classes. Typically, the way that I author my classes in Phosphor is that the constructor and the dispose method are the first things. This is also how I write my C++ code. So the constructor and the destructor are the first things in the class, followed by any read-only properties or get or set properties, so your actual properties of the class, the public properties, followed by all of the methods, followed by protected methods, followed by private methods, and then at the very, very bottom of the class is all of the private data. So the way that I try to structure them is as the user of the class is reading through the class, things should show up in more or less the most appropriate order for that user of the class. So they care most about the public interface of the object and how you construct it and how you dispose of it. Then they care about what methods they can call on that object. Then they care about the protected methods, because if they're going to subclass it, they might want to override some protected stuff. And finally, they care about the implementation details, which is all the private stuff, which is at the very bottom of the class. So you'll see that the same sort of flow of defining a class through all the classes in Phosphor. Excuse me. Okay, then we have a way to get and set the parent of a widget. So the parent of a widget is either going to be a widget or it's going to be null, pretty self-explanatory. Then you can set the parent of a widget. Now, it's always important to read the notes. Children are typically added to a widget by using layout, which means user code will not normally set the parent widget directly. The widget will be automatically removed from its old parent, and this is a null if there's no effective parent change. Probably the most important thing here is that user code will not normally set the parent widget directly. This needs to be public, the setter, because of limitations in the TypeScript language. If I had my way, it wouldn't be public, and it would be like an internal property that only the layout would have access to, or rather it would be, if to make an analogy with C++, I would make, if I had the ability in TypeScript, I would make this parent a read-only getter and not have a setter. And then I would have a private method called setParent, and layout would be a friend class of the widget class, so that only the layout would be able to set the parent. That's the intent of this setter. Because of limitations in TypeScript, it's got to be public so that I can call it from the layout class, and so it's public. You shouldn't use it, but we can still walk through and see what it does. So the first thing it does is that if this is a no-op, so if the parent's not being changed, it'll do nothing. Then the next thing is that if there's a parent and this widget contains that parent. So think about what you're trying to do here. You're trying to set a descendant of this widget to the parent of this widget. That would make for a circular tree. So we guard against that case. So again, this is an example of sweating the details in Phosphor here. If you look at lots of widget libraries that are out there, they don't do this check. And if you actually try to do that and set the parent of one of their widgets, to a child or a descendant of that widget already, it'll happen, and then the library will start acting really wonky, and then you're wondering what's going on. And so we want to sweat the details and prevent the user from shooting themselves in the foot as much as possible. So we make that check.
Chris,
yes.
Can you comment? So I was under the impression that we frequently set the parent to null if we're removing something from a layout. Would that from user code? Is that an exception to your saying we would rarely set the parent, or?
Yes, yeah, that's the exception, is that if you want to remove it from the hierarchy, you can set it to null.
Okay.
But typically what you wouldn't do is set it to another widget, because, you could, if you wanted, there's always going to be exceptions, right? And that's another reason why I made it public. So you can do that, and there might be some really, really rare circumstances where you're really doing some custom stuff, and you want to do that, and you're managing a bunch of messages on your own, and you're implementing, or you're ensuring that you're implementing all the behaviors that are necessary to attach a child widget that way. So you could do it.
Sure.
It's not really recommended, but yes, the recommended way of removing a widget from the hierarchy is to set its parent to null. So yes, thank you for bringing that up. But yeah, that would be the exception of.
Cool. Thanks.
Yep. Okay, the next thing we do is we see that we check to see if the widget already has a parent, and making sure that the parent is not already disposed. If it is, we send that parent a message, and we're saying, hey, your child is being removed, because some widgets care about when their children are being removed. In particular, layouts care about when children of a parent widget are being removed, because they're going to need to schedule a relayout because they've got new stuff or more space now that they need to allocate to all the remaining children. So we go ahead and we send that message to the parent. Then we update the current parent value, because that's what we need to do. We need to set the parent. Then we check to see if the current parent is not disposed. So again, this is you could be setting it to null. So in this case, or some disposed widget, which you shouldn't do, but it could happen. And then we send a message to that widget that says we've added a new child, which is the current widget that we're adding. And then if this widget itself hasn't been disposed, we send ourselves a message that says our parent has changed. Now, child removed and child added, these messages are actually consumed by layouts in Phosphor to, again, handle the reallocating of space. The parent changed message, which is just it's just a static message. There's no contents that ever need to be changed, so it's just a singleton. Whereas these two messages, you have context to add to them. So that's why these are new messages, and we'll see that this is just a statically defined singleton message. We don't actually use this in Phosphor, but you may, as a user, have your own subclass that cares about when the parent of this widget has changed. And so you might decide to re-implement the process message method of your widget subclass and listen for this message being sent to it. And then you can react to it if your widget has been changed, if the parent of your widget has been changed, so on and so forth. The next would be the next most important thing, which is getting and setting the layout of the widget. And so the getter is just returns either whatever the layout is or null. And note that it returns it as a base layout class. So this is done. I wonder if I should talk about this now. For now, let me just say it returns an instance of the layout. We'll see later on why we've actually separated the layout class from the widget class, or the behavior of a layout from the actual widget. And the reason for that is that you might want to implement widgets which hide what implementation of a layout they're using. So you might want to have your own custom layout and force your users of your widget to go through your own API on that widget subclass in order to add and remove children for whatever reason. Like the dock panel is a great example of that. It's got its own set of methods for adding children to the dock panel in particular ways, and it's got a layout implementation, which is the dock panel layout, which actually handles the layout for the dock panel, but it hides that from the user. So the user doesn't actually work with the dock panel layout, it works with the dock panel. And so in order to facilitate the hiding of those implementation details, we separate layouts from widgets. So the user only has access to the base layout class definition, which actually can't do anything. When you'll see when we go to the definition of that class, you must subclass layout to make it useful. And so by handing your user back just a layout object, it's really kind of useless for them. And so that's why that exists like it does. Nevertheless, assigning the layout. Again, let's read the notes. So the layout is single use only. It cannot be changed after the first assignment, and the layout is disposed automatically when the widget is disposed. The fact that it's single use only and cannot be changed after the first assignment is entirely for convenience of implementation. Would it be possible for me to allow the user to swap layouts on a widget dynamically at runtime? Yes, I could, but there's a lot of edge cases that you run into when you start allowing that behavior that are more difficult to code around. Let's take, for example, a box panel class, which uses a box layout internally as an implementation detail. If I decided on the widget base class to allow you to change the layout of that dynamically, the user might come along and grab your box panel and change its layout to a dock panel layout. That doesn't make sense. That no longer works. The box panel can no longer assume that its internal layout implementation, which it set while it was constructed, so it knows that it's a box panel layout. That's no longer a valid assumption. So it can't just assume that its layout is always going to be a box panel layout. And internally, when we see the box panel, you'll see that it does unsafe casting, and which is actually safe because it knows that the layout can never be changed after. So we would have to have coded a way to work around all of that and to ensure that the box panel always knows it's dealing with box panel layouts, or throw an exception when it's not, or something like that. And so for the rare utilitarian case where it might be nice to be able to swap layouts, I decided to take the safer approach and say, sorry, that's not allowed. Figure out a different way to solve that problem. We're going to take the safer approach and say, once the layout's been set, you can always assume it's going to be that same layout object for the life of the widget. So it allows us to separate layouts from widgets, but it also allows us to make assumptions in a particular widget implementation that if we set the layout in a constructor to a particular instance of a layout, that's never going to change out from under us. So the first thing we do is, if you're trying to set the layout to the same thing that already exists, so if it's a no-op, we do nothing rather than raising exception. If a flag has been set which disallows a layout from being set on an object, which might be the case. So for example, a tab bar is a leaf widget in a hierarchy. You don't want to set a layout on a tab bar because it can't have children. And so what the tab bar does in its constructor is it sets this disallow layout flag. And what that is a signal to, not overuse the term signal, it's a marker for the framework to know that, hey, this widget shouldn't have a layout. And so we test for that here. And if the subclass has said, no, you can't put a layout on this widget, we don't allow that. So sorry, you cannot set the widget layout. If a layout already exists, you also can't change the widget layout. We already talked about why that is. And if the layout itself already has a parent widget, this means that this layout has already been installed on another widget, because the only time that the layout parent is going to be set is by the widget itself. So if that already exists, we know that this layout is installed on another widget. That's also invalid. So we throw an error there. Otherwise, we've exhausted all the cases that can fail. So now we know it's safe. We can go ahead and set our layout, and we can also update the parent widget of the layout to ourselves. So this is where that circular reference comes in. So the widget has a reference to its layout, and the layout has a reference to the widget. And so that's the one level of circularity we have in Phosphor widgets that I'm aware of. Okay, moving on. Getting the children. How do you iterate over the children of a widget? Well, there's a method called children, which gives you back an iterator over a bunch of widgets, which are the children of the widget. And in this case, the children of a widget are entirely equivalent to the widgets that are contained with a layout. And the layout itself is iterable over its widgets. So if you have a layout, we just return the iterable or the iterator for that layout. Otherwise, return an empty iterator for those widgets. So this means that you can always iterate over the children of a widget, even if it's empty and doesn't have any children. And so this was probably the first in production example of using the iterator APIs that are defined up here in the Phosphor algorithm package, which was, I think, the very first package we went over in this video series. And recalling just a little bit there, at the time that this module was implemented, and this module or this package, meaning Phosphor widgets, the iterator API for JavaScript didn't exist. That's how old Phosphor is. I think it's pushing 5 years now. And so maybe there were some discussions about defining official JavaScript ES6 iterators, but there was certainly nothing final and certainly nothing implemented by any of the browsers. That has since changed, and there is an official standard for the iterators, which I don't agree with. I don't think it's a good standard, but we should probably have discussions nevertheless for Phosphor 2.0 about whether we want to chuck Phosphor's iterators and just start using regular ES6 iterators, which are objectively less efficient, but that's a story for another day. So you can iterate over the children of a widget. You can also test whether a widget contains another widget. And so by contains, we mean test whether the widget is whether a widget is a descendant of this widget. So that means at any level in the widget hierarchy, you can test whether one widget contains another. And if you think about the algorithm for that, you could think about doing like a top-down search, which would be very inefficient. So you would start at the parent, check all of its children. For every one of those children, check all of its children, so on and so forth, to see if they match that child. But that's actually a very inefficient algorithm. The most efficient way to do it is to start at the bottom and follow your way up the chain, up the parent chain. So rather than testing every breadth-first search, we're kind of going from the bottom up. And maybe you've got a 5-level deep hierarchy of widgets, so you're never going to do more than 5 comparisons, even though some level of the tree might have 10,000 children or 10,000 sibling widgets. So we use a little for loop. This could be done as a while loop or a for loop. I don't know. Based on the mood I was in at the day, it defines whether I use a while loop or a for loop. But you basically start at the descendant widget, and while that is not null, you continue to step up to its parent widgets. And if the parent widget of that widget is this widget, then the hierarchy contains that widget. Otherwise, it doesn't. So a pretty simple algorithm, but it's not immediately apparent that that's the most efficient way to do it unless you've come across it before. Incidentally enough, it's also how the document.body.contains method works in the DOM. They start at the query node and proceed up the chain rather than breadth first down the chain. And then I think for the last few methods, to end our time, I'm going to talk about these few convenience methods. So the first one is a convenience to test whether the DOM node associated with the widget contains a class name. So it has a class. You can add a class to the node's class list. You can remove a class from the node's class list. And then you can toggle a class. And this is basically where we abstract over some differences in browser implementations. So not every browser accepts this third argument. I think IE11 doesn't allow the optional force flag to classlist.toggle. So if you actually provide force, and this is so if you don't provide force, if you basically leave this optional and you just call this with a single argument, force will be undefined based on the JavaScript specification. So both of these tests will fail. So if you don't provide the force flag, then I actually use the default implementation of classlist.toggle because that's supported on all browsers. If you provide force, meaning if it's not undefined, it will either be true or it will either be false. So one of these blocks will execute. And basically the behavior of that force flag is that if it's true, we're going to add it to the class. If it's false, we're going to make sure it's removed from the class list. So this is behaviorally correct according to the standard, and it just abstracts over the differences in IE11 and Chrome and Firefox.